So let's consider one example. So we're going to rewrite this expression in the form of vertex. So what do? From our previous class, recall that when we have quadratic expression like this, we might want to do something that we say the introduction of a constant, which makes it a perfect square. So I'm going to rewrite this in the way that it's going to work for me. So I'm going to do y squared plus 7y plus k minus k plus 7. Now, why do I do this? If I say 3 minus 2 plus 2, you agree with me that this is the same thing as 3. I've not done anything to it. So that is why I'm introducing k and I'm also taking it away, because I don't want to manipulate or change the question that I was provided with. And it's also important that I look for k and k. So how do I do that? The form of vertex form from the previous page is a into x plus b all squared, now plus c. This is what we call the vertex form. So this is what I'm trying to achieve. So how do I achieve this? And that is what I'm about to do. I need to look for what k is, which makes this a perfect square from the previous videos. If you've not seen that, I would suggest you go back and check some of those videos. K is equal to b over 2 multiplied by the square root of a, everything squared. So that's a way to quickly get the k value here. So let me sub k, all these values into what I have here. By the way, the coefficient of y squared is a, the coefficient of y is b, and all I do is to sub it here. So I can tell that a would be 1 and b 7. So 7 divided by 2 multiplied by the square root of 1 all squared. So I could do 7 over 2 all squared. And you can agree with me that that will be 7 times 7, 49, and 2 times 2 is 4. So the k value which I would add and subtract is actually 49 over 4. So let's rewrite the expression y squared plus 7y plus, I would like to write 49 over 4 minus 49 over 4 plus 7. Now you'd see that I've not done anything to this question. What I have to do is to introduce this to k's. Now what we do again is to try to write this in a perfect square form, this one only. Then I'm going to simplify this one independent of the other one. So to start with this one, what we do, if you recall, is to take the square root of the first term, take the square root of the last term, then join them together. You can check up some of the videos in the past. You'll see where we learn all this together. I would suggest you do that if you're not sure. Now, the square root of y squared is y plus the square root of 49 over 4 is 7 over 2, because the square root of 49 is 7, the square root of 4 is 2. So if you expand this, you're going to go back to this question. You can pause the video and try that yourself. And the next thing here is to simplify this. So if I want to simplify this, I'm going to do manipulation of fractions, and of course that is still in one of our videos. You should check that out if you're not sure of how to do this. And we're going to come up with negative 49 plus 28 over 4. Okay, you can do plus there if you want to, but it's not necessary. It's literally going to be, so let me just put it there to make it neater. So to fine tune this, I'm going to get y plus 7 over 2 all squared. Now, because if I'm going to do negative 49 and 28, that would be like 21 negative, so it's going to be negative 21 over 4. Now, if I compare this to the general structure here, you'd see the relationship I'm looking at. Now, it looks exactly like that. So I could tell that A, in this case, is 1. Now, B is 7 over 2. And, of course, C is negative 21 over 4. Now, I've written it in vertex form. That is fantastic.